Hello, and welcome to this Kuali Research webinar. My name is Jen Flock. I'm the Kuali Research Compliance Product Manager. Today, I'm pleased to introduce our presenters for today. Geoff McGregor, he is the Research Administration Systems Manager at Indiana University, and Peter Brown is the Lead Software Engineer at Indiana University. Geoff has been involved with the Kuali research community for over 10 years, including stints as a developer, configuration manager, developer manager, chair of the technical subcommittee. He is currently the manager of research administration systems at Indiana University, and he is IU's representative on the Kuali Research Executive Sponsor Team. Peter joined IU in 2011 to work on Kuali COIC 3.1 and has participated in rolling out a number of Kuali products at IU, including Institute Proposal, Awards Negotiation, IRB, and the new Conflict of Interest and Commitment module, COIC. He also led historical data conversion efforts for the proposal modules, which was no small task, and has acted as team technical lead for 2 years now. So welcome, Geoff and Peter. You can take it from here.
All right, thanks, Jen. This is Geoff, and thanks again to everyone on the call for joining us today. Peter and I are happy to have the opportunity to share our experience with our conflict of interest and commitment implementation at IU. We both come from a technical background, but we thought we might have a broad mix of functional and technical folks here. So we tried to include content that would be helpful to both audiences without being totally overwhelming, hopefully. But whether you're working on an implementation of COI or protocols even, or just considering one, our goal is really to give you an idea of the things you'll need to think about and plan for, give you an idea of the technical problems you'll want to consider, and how we, along with Kuali, ultimately were able to solve some of those problems. And also give you a basic understanding of some of the newer architecture and the newer technology stack, which is quite a bit different from the legacy architecture of the older Kuali products that many of you, looks like you may be familiar with. So with that in mind, we can go to the next slide. Here are the general areas we're planning to cover. So I'll give a brief background of IU's history with Kuali and kind of how we got where we are today. We'll do a technical primer, and then talk about some of the foundational concepts of the software architecture. Then we'll go over some of the specific integration points that we engineered, which it sounds like is of high interest to people. And then conclude with a look at our project in particular and just some of the resources and timeline that we had for our project. So, so first up, just some background on Kuali.io. So we can go to the next slide here. As many of you know, IU has a pretty long history with Kuali. We were an initial founding partner way back in 2005, and over the years have continuously added to our on-premise module implementations as they were developed and delivered. We also ran the COIC system for a while, which was kind of a precursor system to Kuali COIC. We use that for human subjects, protocols, and institutional review board management. And then we upgraded from COIC to Kuali COIC in 2013. So if we go down to the next slide, in 2015, we upgraded to KC 5.2.1, which at the time was the latest version of KC. For those of you who maybe aren't as familiar with kind of the Kuali products, you might hear the words Kuali COIC and Kuali Research tossed around and often used interchangeably. We might do that here today, fair warning. But just for some background on that, for many of the years of development, the product was known as Kuali COIC up through the release of 5.2.1. And then subsequent releases, it was just kind of rebranded as Kuali Research, just to kind of be more clear about what the product was doing. But it's really the same product. That's kind of the way I think of it. Anything version 5 or below is kind of called Kuali COIC. Subsequent releases I call Kuali Research, but they're both a continuation of the same product. So we got to 5.2.1 on premise. After that, there were more releases of Kuali Research. At IU, for various reasons, we decided to stick with 5.2.1 for a while. As you saw, we had done a whole lot of work, a whole lot of implementations over the past several years. And so we just wanted to have a little bit of stability for a while and stick with 5.2.1. But we do have a plan to work on an upgrade to the latest version in the future on a more gradual timeline. But then if, 2016 rolled around and there started to be some discussions about COI. We never actually did implement KC COI. There was a COI module in KC 5.2.1, but we had a web form that we had used for several years for that process, and it was working fine, so we never really felt the need to implement KC COI. But during 2016, there started to be some conversations between the research office and the general counsel's office to start, in addition to disclosing research conflict of interest information, also to disclose conflict of commitment, which would be additional things like outside professional activities, use of university resources for non-work functions, and just things like that that weren't covered in the existing research disclosure form. Our current form was not going to work for that, but we knew that Kuali had a conflict of interest and commitment module in their development that was intended to be flexible enough to collect all of that disclosure information as much as we wanted. So we decided to pursue that as our solution. But then when we made that decision, there were some questions that we had to address. So one requirement for the new system was that it would have to integrate with our current 5.2.1 system on premise. We had a pretty tight timeline for the initial rollout. So we had a desire to implement that in the cloud to reduce implementation time. But then again, we had to ask the question, would we be able to integrate that with our on-premise older version of KC? And since we're here today doing this presentation, you can probably guess the answer was yes. All right, so next slide. That's just some background. Now we can get into the fun stuff, speaking developer. So before we get into the details of how we made this all work, I'll just spend a little bit of time talking about the software architecture that Kuali is using to build these new modules like COI and protocols. Because it's really a key concept, understanding how we were able to make this work, how we were able to make some of this run on premise and some in the cloud, is having a basic understanding of application programming interfaces or APIs, which I'm glad everybody got that question correct. So that was nicely done. Sounds like we have at least a fundamental understanding of that. So for some of you, some of this stuff might be review, but please bear with me, because again, these concepts are going to be important, and there might be some folks on here which, for which this will be useful. So next slide. APIs, just a way for computer systems to talk to each other. Here's just one simple example of how an API might be used. There's some acronyms on here that you may not recognize. Don't worry about those just yet. We'll get into those. But the point here is that conceptually with APIs, we're not necessarily doing anything new from a business standpoint. We're just doing it in a different way. So, one way we're using APIs with COI-C is adding users into the remote system. This is a pretty common requirement for most systems. In the old days, I don't know, maybe this never actually happened, but just humor me, you might have had to call or email someone directly who could manually enter that information into a spreadsheet or a database. These days, adding users to a system like COIC can also be accomplished using a web form, where a person can come on to a web browser and go to a form and interact directly with the computer system. And then with APIs, you've got computer systems talking directly to each other with no people involved at all. But the interaction itself is very similar as far as what has to happen. So you have to know how to reach the recipient. You have to authenticate that you are who you say you are. You have to have a dialogue where information is transmitted and analyzed for problems. And then the receiving party has to be able to do something with that information. So if we go to the next slide, just building off that example, here's what the person to system interface looks like. So it's a pretty typical web form where you can enter information about a user and then submit it. We've all probably seen screens like this before, pretty straightforward. So if we jump down to the next slide, here's kind of what that same thing looks like using a system-to-system solution. So if you look, if you can look past like the brackets and the weird formatting, it's really just passing all the same data that you would have entered on the web form. It's just you're passing it in a way, a computer system is passing it to another computer system in a way that other system knows how to read. So this particular example is a format called JSON, which stands for JavaScript Object Notation, which is a very common format these days for system-to-system interaction, and this is what the Kuali APIs use. APIs, other common formats are XML, or even in CSV, or there's really any number of formats. The important thing is that both systems have a common understanding of which data format they're using to pass data. So next slide. Just a little bit more about APIs. There are many different kinds of APIs. The type that we're using and concerned with are REST APIs, or RESTful APIs. We won't get into the weeds about all the particulars of what REST APIs are. We could spend hours on that. We won't. But the important thing to understand for our purposes is that they're typically built on the Hypertext Transfer Protocol, or HTTP, which makes them a great choice if you want them to be available to remote systems over the internet. REST APIs also have standard methods for interacting with them. So developers who learn to use REST APIs can expect some consistency in standards when they build APIs and when they consume APIs built by others. So down at the bottom here is a quick example of a REST API call. And what this call would do is it would update some of the data in my user record. So the highlighted portion is the API that we're calling, which kind of looks familiar, right? It's like almost like something you might type into a browser. And then the other thing to highlight here is that the URL contains a reference to v1. So this illustrates that APIs can be versioned, which is very useful. So if an API is going to change in a way that would disrupt how a client system expects it to work, the developers can just, instead of replacing the existing one, they can create a new version of it. So then there might be two APIs. There would be like a v1, which stays the same as the behavior is the same as it's always been. And then a v2, which has some new change or capability. So the nice thing about that is it doesn't break client systems or force them to immediately go change their code to conform to the new version. They can continue using version 1 for some period of time, and then when they have an opportunity to cut over, then they can switch to using version 2. Okay, so next slide. So just to review some of the things that are beneficial about APIs, they're good choices for distributed environments. They have real-time capability. They're less brittle and susceptible to breaking changes than some other common ways to integrate systems, which kind of brings up the question, APIs are a good choice compared to what? The other common way that system-to-system interaction takes place pretty often is using something like an ETL batch process. So batch processes, or batch job, those are just an automated program that typically run on a schedule. So they may run hourly or nightly or weekly or whatever to facilitate some interaction between systems. So oftentimes those are passing data between two systems, and it runs some kind of process to extract the data, transform it, and then load it into the other system. And very often that's actually happening. That's happening at the database level. So this is referred to as an ETL process, ETL being an acronym for extract, transform, load. And often this kind of thing requires additional infrastructure, like a shared location where a file drop can occur. One system takes an extract and drops it, and then the other system picks it up. So I don't want to pretend like those are all bad. Batch process they're fine. They've been around a long time. They'll continue to be used. There's not a bright line distinction. You can have a batch job that uses APIs, for example. That's actually the case with one of our integrations. So we have a batch process, but it's using the COI APIs to load data instead of an ETL process. And ETL processes still might be a good choice in some cases, but generally modern architectures are trending toward using APIs instead of database to database ETL processes where possible, for many of the reasons listed here. So case in point, many of you may have heard of something called the Jeff Bezos mandate at Amazon. This is a memo he sent out around 2002, so a while ago, but basically commanding that all communications between systems must use API service calls over the network, and that those APIs must be capable of being externalized to the outside world. If you make it down to number 6, that's pretty harsh. I don't know if anyone actually ended up getting fired. But the point here is people look back at this decision for Amazon as really an important pivot point for them that eventually allowed Amazon to expand just beyond just being an online retail outlet and becoming a leader in cloud computing and cloud services. So as you might imagine, 2002, that was a while ago, but Amazon was way ahead of its time. A more typical architecture for software built in the early to mid 2000s looks something like this, which is often referred to as a monolith architecture. We refer to the Kuali Research web application as the monolith because it was kind of designed this way. So you have your different, and this is a little bit of an oversimplification just to illustrate this, but so you have your different functional modules in here, but they're all in one big giant project, one big giant application. You may have common concerns like user management. All these modules need to be able to do user management. And so you have a layer of the code in there that handles that. And then, communications and integrations with other systems happen down at the database level using, typically an ETL process or something similar. And so that's what that is. So if we move ahead a little bit, we start to see some more modern architectures like a modular architecture. So in this case, those functional modules have been broken out into their own standalone applications, and they still talk to each other, but now they're talking to each other using API calls instead of just kind of within the code itself within the application. But as we can see here, we still have some common concerns such as user management. So now we have kind of a user management piece within each of these standalone applications. And they still talk to external systems. Those might be via APIs. So now we have, since they talk to each other via APIs, they have APIs available for external systems to talk to them if possible. So now we might be starting to see a mix of API calls and there's still databases involved here. So there might still be some batch ETL as well. But this isn't necessarily ideal because we have, these 3 different user management, this kind of shared function being replicated 3 times. So if we move on to the next slide now, we can see, kind of another step here, which is sometimes you'll see this referred to as a microservice architecture, where now we've taken that common user management component and broken it out. So now it's its own standalone app, but we have just one single area, one single place that takes care of user management, and then all the different functional module apps can rely on that app via APIs to handle user management. And then so just kind of the final step here is kind of what we're going to be looking at today, which is the distributed microservice architecture. So here we have our standalone functional modules, we have our user management piece that's been broken out, and now these different pieces aren't necessarily even living in the same data center. They can be distributed to various places in the internet. So on-premise, in the cloud, and different clouds. All of that is possible here with this kind of architecture. So with that, that's kind of some groundwork. Hopefully that wasn't too much, but now we're going to really start looking at, the good stuff that people are interested in, which is how we got everything set up and how we are integrating with the cloud. And for that, I'm going to turn it over to Peter.
Yeah, so I wanted to give a little bit more detailed overview of IU's current setup and some of the technologies and tools we get everything talking to each other. So if looking at the next slide here, you can see kind of three columns of components. On the left, we just have our regular old Oracle databases. We've hosted those at IU forever. In the middle are four applications making use of those databases. In the blue are just our KC and Rice monolith applications. Again, hosted at IU. Our KC application is a pretty heavily customized version of 5.2.1. And then in the purple are two newer applications, which I'll talk about in detail here in a second. And then on the right are the two applications which are currently being hosted by Kuali Co. So looking at the next slide, we'll talk about the user sync batch first. So Geoff kind of mentioned that we have a batch job using some of our RESTful APIs, and that's what this one is doing here. So next slide. This was written, just a regular old Java batch application written by IU. It runs overnight, takes a couple seconds each time to run, sometimes as long as a minute. It queries Rice database looking for people with updated timestamps, whether that's a username or a first name, last name, or a new user altogether. And then it uses Kuali Co's RESTful APIs to push that data out to the hosted core application, giving the hosted environment all of the user information that it needs. The next data stream here, so if you jump ahead one more, is the Research Lite application. This allows our local KC and Rice databases to talk to the hosted COIC via this application. Research Lite was provided by Kuali Co. It was customized a little bit by IU in order to get it up and running within our Docker environment. But for the most part, it's exactly what Kuali Co provided to us. It's constantly running. It's basically acting as a middleman. The hosted core application talks to COI, but they only have like a bare minimum amount of user information to allow for logins and whatnot. In order to get more detailed information like roles and unit memberships and do so live, it uses the Research Lite application. Research Lite doesn't have a database. It doesn't store any information. It basically provides a layer of APIs that COIC and core can use to access IU's data without Kuali Co needing our database credentials. Kuali Co doesn't even care what kind of database we have. All they care about is that Research Lite is running and returning data when asked. We'll jump 2 slides ahead. And for the last data flow, this is how KC web app talks directly to the COI web app. Let's jump one more slide there. For this one, there's no new separate helper application. Instead, we've customized KC's Java code to make use of COIC's APIs whenever somebody loads one of the contact pages within KC's modules. This happens in real time and displays relevant COI information just like any other data point completely transparently to the functional users. Setting up this code within KC took kind of a moderate amount of effort initially, but then has been pretty solid. And of course, since we show the data in KC, our reporting team wants to be able to access that as well. They can use the exact same APIs we're using to get the data themselves, or one of our recent tasks has been to set up API endpoint within KC so that reporting can query KC, KC can ask for data from COIC and then hand it back to reporting. It's a little bit outside of the scope of this talk, but I'm happy to share more information if anybody wants to know more. And with that, I'll turn it back over to Geoff, who'll start talking about some of our recent initiatives regarding groups and units.
Thanks, Peter. Yeah, so this is a fairly new integration that we had to build. So we're starting to use for COIC something called the department viewer role. And what that would do is it allows people to be assigned the role of a viewer at a particular unit level or a department level. And they would be able to see the disclosure submissions for people that are kind of under their purview in their unit. So, you know, in their unit and any units that are kind of underneath that unit in the university organizational hierarchy, they would be able to see those disclosures. They would not be able to see disclosures for people that fell outside of their unit. And this is kind of, so for other roles in the system previously, such as, administrators or reviewers, those roles we were actually assigning in our local Kuali Rice instance, and then Research Lite would be able to resolve those roles for the COI application. But with, I think, we're starting to move now towards using the Kuali core groups functionality for assigning roles. And the department viewer role is the first one that we're trying to do that with. But so, the change there will be that, instead of querying Rice through Research Lite to see where these role assignments are, it'll just be querying the groups application directly. But so in order to make that work, we needed to kind of replicate our unit hierarchy within core groups. So basically, for each unit that we have at IU, we need to create a group within Kuali groups, and then we need to make sure that we have our hierarchy correct. So we need to establish those relationships between, a particular unit, and then what's the parent unit for that unit, et cetera, et cetera, et cetera. So the way we did that initially is, you can do just an export into CSV format, and then Kuali can do a one-time load of all your groups into core groups. But then the question becomes, how do you keep those in sync? What if we make a change over on the IU side to the group, add a new unit, move a unit within the hierarchy? How do we make sure those are being reflected over in Kuali groups? We don't really want to have to do that manually, and remember to update both systems. So what we did is we built a hook into our, so when people go to modify or add units in KC, they use something called a maintenance document. We added some code within the maintenance document process for units that will actually go out and query the group's API provided by Kuali. And then whatever change we're making in IU will then be reflected over in Kuali groups within seconds. So if a new group is added, or if a group is moved, or a unit, I should say, if a unit is added or a unit is moved, as soon as that is, as soon as somebody makes that change and submits it on the IU side, behind the scenes, IUKC will call out to the Kuali API and make that exact same change over in Kuali groups. So the next slide. So another problem that we had to solve was, how are we going to do reporting on this data? There's a couple issues there. We needed to be able to access the data, and we needed to be able to, in some cases, for some of the reports that we were doing, we needed to be able to join that data with data coming from other systems. So we really wanted to have the data available on premise in our data warehouse, to be able to do those kinds of joins and to be able to kind of optimize what we needed to do for reporting. So we were able to do that. So the Kuali hosted instance is a MongoDB, but what they do is in our reporting environment, they were not as familiar with using MongoDBs to do reporting. So that's actually translated to a MySQL database. It's a MySQL dump file. Now, interestingly, so the MySQL database is not like it's not relational. So they don't take the MongoDB structure and turn it into a normalized structure. What it is really just a replication of the MongoDB in MySQL format. So essentially it's we looked at the JSON string before. Essentially what you have in the MySQL database is a pretty simple table that has one column, which is just a big chunk of JSON, which represents the disclosure information. But our reporting team was able to work with that. They can query a JSON string and pull out the data that they need to pull out. So that MySQL file gets put into a drop spot on S3 nightly. We have a batch process running locally that goes out, it grabs that extract, and then it imports it into our reporting environment. And then we have Tableau reports that are available that are built on top of that data. So then if we jump down one slide, this is just kind of an example of what that looks like. So just kind of illustrating that you can really pull all of the useful data out of the disclosures to provide to people in the departments that might be interested in it. All right. So then we'll just spend a few minutes before taking questions, just looking at our project timeline and resources. So timeline, we really initiated the project in January of 2017, and we're able to roll out the COI, the initial COI only form in July of 2017. And that was a pretty tight time frame, but there were some regulatory reasons we had to do that, and we're able to make it happen. One of the things we did there is before rolling it out to the whole university population, we had a 2-week limited pilot with some targeted users and targeted departments, and that proved to be really helpful because we did get some feedback, and we're able to incorporate that feedback into the form before rolling it out to everyone. When it might have caused a lot more reaction for people. We were able to solve that problem ahead of time before it got in front of a lot of people. So I would definitely recommend something like that. And so then our next step was to then build in the conflict of commitment portion of the form and include those questions in the form. So that took a while, and a lot of that was, we migrated to the new form builder structure, which was a pretty big change. It was under development during that time, actually, and then add the conflict of commitment questions. And then we did our full rollout in September of 2018. So just recently we started collecting that data. And I think we've gotten somewhere, so as of now, we've gotten somewhere in the neighborhood of, I want to say 14 to 15,000 disclosures submitted. And our experience, at least, once you send out your initial communication, you're going to get a pretty heavy hit of people coming in and doing it. But the heaviest hit that you're going to get is like 2 or 3 days before the deadline, because that's when all the slackers realized, oh shoot, I better go submit this thing. So that was our experience anyway. But yeah, and I think as far as the timeline goes, just because, particularly this kind of second phase of building in the conflict of commitment questions, since the new form builder was kind of under development, a lot of that stuff was under development. We were the first school that was going to be rolling out some of those changes. That took a little longer than it might otherwise take. So nowadays, you probably wouldn't need as much time to roll something like that out. But for us, it did take a little bit of time to get all that in place. And then if we look at the resources, these kind of, went up and down a little bit over time. This was not a constant, and these are kind of rough, but this is generally what we had on the project from the IU side. Almost a full-time business analyst on this project, and then others kind of spending a decent amount of their time on it. And then on the technical side, between Peter and I and some of the other developers on the team, I'd say between all that, it was about a half a technical resource for that time period. We had subject matter experts from the business offices who were very involved with this project. Not their full time. They had other jobs they had to do, but a fairly decent amount of their time was spent on this. And then of course we had our executive sponsors, General Counsel, Vice President for Research, and Vice President for Information Technology.
Thank you, Geoff and Peter, for sharing that detailed explanation of how your integration functions at IU. Let's see, attendees, it looks like we've received some questions, but please take this opportunity to submit more. You can do that by hovering over the bottom of your webinar window and click on the Q&A button. And then feel free to submit a question. Even if you want a personal answer, you can just note that as private and we can get back to you directly. So here is our first question. Are you ready, or do you have plans to implement future new Kuali Research modules at IU as they mature?
Yes, we do. Yeah, like I mentioned, we are on 5.2.1 now, and that's been working well for us. But yes, we do want to get on to the latest version of Kuali Research to take advantage of some of the work that's going on in those modules and some of the newer enhancements coming out. And we do also plan to implement Kuali protocols as well, the new protocols module that's being written in the new tech stack. We're still waiting on some of the features to be developed for that to get to the point where, you know, it'll serve our functional needs. But yeah, we do definitely want to implement that as well.
Thanks. That sounds great. Let's see. Next question. Given that you're one of the first schools to go live with this sort of implementation, what sorts of technical resources did you use for help while you were setting this up?
Yeah, so I'd say, yeah, a lot of this was new for us as well. You know, this was kind of new architecture. So, I mean, we relied on Kuali, obviously, to help. You know, they pretty much built Research Lite, and they helped us set it up and configure it. We obviously have a local, so, you know, my team as a team of me and me and 4 developers, and so we, you know, we had some expertise with building things like the, you know, the Java job that does the core user sync. And we have some other teams locally at IU as well that helped us out. You know, particularly the enterprise systems integration team, which was kind of pioneering some work with Docker, for example, which is what we use to ultimately set up Research Lite. So they were a big help to us as well. But yeah, you know, a lot of it was just a learning experience for us and a learning curve. If there are other teams out there that are kind of in the same boat, we're certainly happy to pass along whatever knowledge or answer whatever questions you might have. You know, feel free to reach out to us directly as well for that. But yeah, it was pretty much just, you know, trying to learn it as best we could.
That's awesome. Let's see, next question. How often do you change your JSON conversion program based on Kuali changes?
This is Peter. I don't think we have yet. The APIs have remained constant enough, at least within the versions, that we're still using the exact same parsing structures that we set up back in 2017. Yeah, I don't think we have had to make any changes yet.
Sounds good. Let's see, next question. If I'm running the current version of Research, do I need Research Lite?
No, I don't believe you do, because so the current version of Kuali Research, so those APIs that Research Lite provides for COI to talk to, those are available, I believe, and Jen, correct me if I'm wrong, but those are available, I believe, just as part of the current Kuali Research module. So you would not need Research Lite. I think is specific to, you know, folks like us with a 5.2.1 instance on premise. I don't think you would need it for if you had the latest version of Kuali Research.
Yeah, and that's one of the things that we're looking at as we move forward. To date, this is Jen speaking on behalf of Kuali now, but for the folks that have gone in this direction, in the hybrid model where they have a hosted monolith, to date, the schools implementing have had 5.2.1 running. So it's been Research Lite to date, but moving forward, it should not be needed in the future over time. So the next question, it looks like got time for a few more. When you upgrade to new modules like the protocols module, will you be implementing on-prem at IU or SaaS with Kuali? Or have you even made that decision yet?
Yeah, we haven't made that decision yet. You know, like I said, one of the reasons we went SaaS with COI was because of, you know, timeline constraints and technology constraints. You know, we weren't familiar with running this kind of new architecture in an enterprise context locally. So those are some of the reasons we chose SaaS, and we've been happy with it so far. But yeah, as far as protocols, that's still under evaluation for us.
Okay, the next question, and this might be more of a functional question, we might have to follow up afterwards, but how does routing work for the commitment end? Does data go to individual department? What about human resources?
So yeah, so routing, that's an interesting problem that we had to tackle. So for us, the conflict of commitment questions, those don't go through any kind of routing and review process. So if a disclosure has, the first screen somebody sees is you know, a set of screening questions to determine whether they have to fill out the you know, answer the research related financial disclosure questions, the conflict of commitment disclosure questions, or both. And if they only have to do the commitment questions, then once they submit that, it goes straight into approved status. And then that information is provided to the departments via reports and via the unit viewer role that I discussed. And if there have to be corrections or changes to the disclosure or additional information added to disclosure, you know, they can go in and do that at any time. But that kind of thing is really managed more at the department side. I do think there is some desire at some point in the future to have more sophisticated routing for that process. But right now, it's those just go straight to approved, and then that information is distributed to the departments to manage.
Great, thanks. Let me see. Knowing what you know now, what do you recommend to others considering doing something similar to the integration approach you took?
You know, I think one thing at least that we're looking to do in the future is, you know, around that kind of user provisioning process. You know, we initially went with kind of a one-time batch job there for a variety of reasons, but basically, you know, I think doing those in real time, if possible, I would recommend, instead of a nightly batch load of users. And that's something we're going to look at, but so for us to do that, we would need to hook into the process that provisions our RISE database. And that gets really, I don't know, maybe it's just an IU thing, but that whole process gets really complicated. And so we chose to just, you know, go straight to the database there and pull that data out and do a nightly batch load. But we do still have some cases where users, and this is rare, but users will try to enter the system and their record hasn't been loaded yet. And so they have to wait a little while. But, you know, that sends a notification to somebody, they have to be approved, et cetera, et cetera. So I think I would, you know, if possible, I would recommend user provisioning in real time. And then the other thing that I mentioned was, you know, that pilot period that we did for the initial rollout, that was really helpful. I think everybody agrees that was a really good idea. We saved ourselves a lot of headaches just by, you know, getting some of the usability issues that people encountered out of the way and taken care of before releasing it to a broader population. That's all I can think of. Peter, can you think of any others?
No, I mean, on the technical end, I think most of our thing was just trial and error with some of these new technologies, but yeah, I don't know that we necessarily would have done anything differently looking back now.
Thank you. The next question, looks like we have time for a few more. Were there any difficulties with regard to performance during this implementation?
I would say generally the performance was very good, actually. You know, I always get, having gone through a number of implementations, like especially when we do the initial rollout and it's more people hitting it than, you know, the typical number of testers, I get really nervous. But the system, for the most part, performance-wise, like it performed beautifully. And I know, yeah, at QualiGen, I think you guys did do some load tests and stuff before the initial rollout, so so that was comforting. But yeah, it really performed really well. The only, you know, I think with our recent, like I mentioned, that probably our heaviest volume of load had been within those within the 2 to 3 days before our deadline for the conflict of commitment submissions, which just happened at the end of October. And we did see maybe and I don't, you know, this is still kind of under investigation, but, you know, potentially a little bit of a performance hit there. So, you know, maybe going forward when we're approaching those deadlines, we asked to scale it up a little bit on a temporary basis. But yeah, for the most part, performance has been really great.
That sounds great. Yeah, we did try to do some performance testing in advance. So it's good to hear. So it looks like there's a few questions that I think we'll follow up with folks on after. We are running out of time. We need to wrap this up. I just want to say thank you, everyone, for joining. And thank you, Geoff and Peter, for such a great presentation. It was really informative.
Yeah, thank you.
Thanks.